I am Anil Kumar. Welcome to my series on vectors. In this video, we'll discuss a test paper. I have picked up 12 questions from previous 5 years test papers. These should help you to understand the topic and also improve your performance in the test. The questions here are based on Introduction to Vectors, where we are going to include vector geometry, vector algebra, scalar multiple, and dot product. There are 12 questions in all. You can, in between, anytime, pause, answer the question, and then look into my suggestions. Let's begin with question number 1, which is straightforward. Fill in the blanks. Identify minus 10 degrees Celsius temperature as scalar or vector. Now, we do have positive and negative signs for temperature, but that does not give you direction. So whenever we talk about temperatures, it is a scalar quantity. Very important to remember, as sometimes students think this is a vector, which is not true. Part B. Express north 25 degrees west as a true bearing. Now, bearing angles are always measured from north in the direction, clockwise direction, right? We are given from north 25 degrees west. That means something like this. So that is 25 degrees west, right? So this is the direction which is given in the given question. What we need to write is the true bearing angle. Now, bearing angles are measured clockwise from north. So that means we are looking into this angle, correct? So that should be 360 minus 25, clear? So it should be 360 degrees minus 25 degrees, right? So that should give you 5 take away 2 is 3, 335 degrees. So that is the true bearing angle, correct? So the true bearing angle is 335 degrees. C. Express as single vector. So vector FE minus vector GE plus GH. Now whenever we type, bold letters will indicate vectors. Now minus GE could be written as plus EG, so I could write this as F to E, right, this vector, plus E to G, plus G to H. So clearly we are moving from F to H, correct? F to E, E to G, G to H. So that is how easily you can actually do or solve such questions. Next one here is determine vector AB given. So these are the position vectors given. A minus 3, 2, B 3 minus 5. So in this case, what is AB equals to? So AB will be OB minus OA, right? Basically, it is OB minus OA, correct? That is from A to B. So you could do like this. So B is 3 minus 5, take away minus 3, 2. So 3 minus minus, that gives us plus 6, and minus 5 minus 2 gives us minus 7. So that is the vector AB. So you could write vector AB as this is written in the column form. You could also write this as 6i minus 7j, right? Where I and j are unit vectors, and that is also correct answer, right? So you could write AB also, vector AB as 6 minus 7. Now let's take question number 2. Given that magnitude of A is 6 and magnitude of B is 4, and the angle between them, A and B, is 37 degrees. Calculate A dot B and A plus B. So there are two parts to this. So first let's do A dot B. So the dot product is magnitude of A times magnitude of B times cos of angle between them. So angle is given to us. So we can write this as 6 times 4 times cos of 37 degrees. Correct? Now let's calculate. So we have 6 times 4 times cos of 37 degrees. That gives you 19.167, right? Which you could round as, let's say, 19.2. So that becomes your dot product. Now let's find what is the sum of these two, B. Important thing to understand here is that when we are saying that magnitude of A and B is given and the angle between them, then basically, let's say this is A for us, right? And magnitude of B is, let's say this is B for us. The angle between them is 37. But when you do when you add the vectors, in that case, you draw a vector parallel to B here, right? And the resultant is the sum. So A plus B is this vector. That is A plus B. Clear? If this is A, this is B. That is also B. Now, the angle which we take is not 37, but it is 180 minus 37. Clear? To apply the cosine law. So we have 180 minus 37 equals to 143. So this is the 143 degrees which is being used, right? So A plus B, so we have both magnitude and direction, right? So let's first calculate the magnitude of A plus B, which is going to be, let's say square of this, let's calculate, we'll do square root, is A square plus B square, magnitude of A square plus magnitude of B square, minus 2AB cos of this angle, right? So minus 2AB cos of the angle 143 degrees. Clear? So in this case, it is going to be 6 square plus 4 square minus 2 times 6 times 4 times cos of 143. So we get 6 square plus 4 square minus 2 times 6 times 4 times cos of 143, which is equal to 90.33. So the magnitude of A plus B is going to be square root of 90.33. So let's do square root of our answer, and that gives you 9.5. So we get this as 9.5. So this is A plus B magnitude is 9.5, right? Now we need to find this angle which it makes with A. Only then the vector is completely defined. So you should have direction and magnitude. We found the magnitude as 9.5 units. Clear? To get this angle, we can use cosine law or sine law. One angle, we have 3 sides, sine law should be used, correct? So now to find that, we will use sine law. Okay. So let us say that we now calculate the angle alpha which the sum makes with side A. So in that case, sine alpha over side B, right, this side B, should be equal to sine of angle 143 degrees over A plus B magnitude, right? So magnitude, is that clear to you, right? So let's do it. So we get sine alpha equals to magnitude of B times sine of 143 degrees divided by magnitude of A plus B. Clear? So that is magnitude of B is given to us as 4, right? Over, we just calculate this as 9.5 sine of 143 degrees. Let's calculate this. So we get 4 divided by 9.5 times sine of 143, which is 0.253, let's say 4. Now alpha is sine inverse of this, right? So we'll find alpha, the angle, as sine inverse of 0.2534, which is, so we do shift sine inverse of our answer, and that gives you 14.67 degrees, correct? So we can say that A plus B makes an angle of 14.7 degrees with A, right? So we have our answer here. So we know now that A plus B, the vector A plus vector B, has a magnitude of 9.5 units and is 14.7 degrees with vector A. Clear? So that is how you are going to get the sum of these two vectors. So I hope the steps are clear. Very important to understand is that when you want to find the sum, you should calculate both magnitude and its direction. Direction can be given with reference to one vector, any one of those two vectors. Clear? Now here is question number 3. I'd like you to pause the video, answer it, and then look into my suggestions. Number 3, given vector P as 3i minus 5j, Q as minus I plus 4j, determine x if 4p minus 3x equals to 7q. So let us assume that vector x is let's say AB, right? So let's say vector x is AB. In that case, let's substitute the values and find the answers. We get 4p, so 4 times p is 3i minus 5j. I can write 3 minus 5 minus 3 times x, which is AB, right, equals to 7 times q, which is minus 1, 4. Clear? So that gives you 4 times 3 is 12 minus 3a, and 4 minus 5 is minus 20 minus 3b equals to minus 728. Clear? So from here we actually get two equations. The first one here is 12 minus 3a equals to minus 7, right? So from here we can find the value of a. The second one is minus 20 minus 3b equals to 28. From here we can find b. So let's find a first. So taking 12 to this side, we get minus 3a equals to minus 7 minus 12. So that means minus 3a equals to minus 19. So a equals to minus 19 over minus 3, or 19 over 3. As far as b is concerned, we get minus 3b equals to 28 plus 20. So minus 3b equals to 48. b is equals to 48 over minus 3. So which you get as 3 times 1, negative, right? So 18 is 6. So b is minus 16. Correct? So you get the vector x as equal to 19 over 3i minus 16. These are unit vectors j. Is it clear? So that is how you can actually find the solution of this question. Let's move on and take question number 4. We are given two vectors u and v. Determine if the above two vectors are perpendicular. So perpendicular means dot product should be 0, right? So that is the concept. So let's find the dot product. So let's find what is u dot v equals to. So we have here minus 3 minus 2, 2 dot 2, 5, 8. So that gives you minus 3 dot, this gives you minus 6. When you multiply these two, you get minus 10. And when you multiply 2 and 8, 16 plus. And that is indeed equals to 0. So this implies that u and v are perpendicular. Clear? Let's take the next question. Given a and b are perpendicular vectors such that magnitude of a is 5, magnitude of b is 3, evaluate this vector. Okay, so now we are given that a dot b is equal to 0. We have to evaluate this, which is 2a minus b dot a plus 4b, correct? So let's do the dot product. We get 2 a dot a, right? Plus 2 times 4, 8 a dot b minus b dot a. Now b dot a and a dot b are same things. Dot product is commutative. Minus 4 b dot b. Correct? Now a dot a is magnitude a square. And a dot b is given to us as 0. A dot b is 0. And here we get 4 magnitude of b square. Clear? So we get 2 times magnitude of a is 5 minus 4 magnitude of b is 3 square. So we get 2 times 25 minus 4 times 9, which is 50 minus 36. Okay, so we get 4, take away 1, 14. So that is the answer, correct? The next question here is question number 6. Given the points P, Q and R, show that P, Q and R are collinear. So you can actually pause the video, answer this question, then look into my suggestions. Now in question number 6, we need to show that 3 points are collinear. So we could do that if we have scalar products. That is to say, if we prove that PQ is some constants times QR, then they are collinear. This is the concept. Is it okay? So let's find what is PQ and what is QR. So PQ will be what? P to Q means 1 minus, so x values 2 minus 1, let's do like that, 2 minus 1, 1 minus 3, 1 minus minus 2, 1 plus 2, right? Which is 2 minus 1 is 1, 1 minus 3 is minus 2, 1 plus 2 is 3. Okay, so that is the vector PQ. Now let's find what is QR. So QR will be 6 minus 2 minus 7 minus 1, 13 minus 1. Which is 6 minus 2 is 4, minus 8, and that is 12. So 1 minus 2, 3, 4, minus 8, 12, right? So basically, we can say that PQ, if I multiply PQ by 4, I get QR. So 4 times PQ is QR. Or I could say PQ equals to 1/4 of QR. That means they are collinear. Is that clear, right? That is how you're going to prove it. Here is question number 7. The vertices of parallelogram ABCD are given to you. Using vector, determine the coordinates of D. So let's sketch one. Okay. So let's say this is a parallelogram. That means the opposite sides are parallel and also equal, right? So we have A, B, C, D. Let's write them in order. Coordinates of A is -3, -4. Of B is 5, -3. For C it is 1, 4. And for D we need to find, so let's write XY. Now, since we need to find the coordinates of D, what we could do is that we know AD is equal to BC, right? So that should help. So we know AD, vector AD is equals to vector BC. Now what is AD vector? So vector AD is x minus -3 means +3, right? And y -4 means y +4, correct? Equals to B to C means 1 minus 5 and 4 minus -3 means 4 + 3. So that means we have x + 3 equals to 1 minus 5, which is -4, correct? And so that gives us x equals to -7. The other one is y + 4 equals to 7. So y equals to 7 minus 4, which is 3. Right. So we get the vector D as coordinates for D will be -4, 3. Is it clear? So we get this as -4, 3. So that is part A. Well, x was -7. I wrote -4. It is -7 here. So good time to see it. Okay. So we got the coordinates for point D. Point D is -7, 3. Right. So we've done part A. Part B. Using vectors, determine if ABCD is a rhombus. Now, to show that ABCD is a rhombus, we need to find magnitude of AB and magnitude of BC, right? Then we can show that both are equal, only then it is a rhombus. So let's find magnitude of A to B. So AB magnitude will be equal to square root of 3 minus, let's do 5 minus, that means 8 square, plus -3, that becomes -1 square root, correct? Which is 64 plus 1 square root, or square root of 65. Let's find BC magnitude, right? Okay. Magnitude of BC, we already found BC is this, which is 5 minus 4 square plus 4 plus 3 is 7, 7 square, right? So that is 16 plus 49 square, which is also equal to square root of 65. Now, since magnitude of BC is equal to magnitude of AB, we know this parallelogram is a rhombus. Now, I'll recommend that since we are given these 3 vertices, you should calculate their lengths and then prove part B. So in case you have done some error like this, at least half of the question will be right, correct? 8. A circle has center O and radius 6. OA is a vector 6, 0. OB is a vector -6, 0. And OC is vector 5 square root 11. Determine a vector of magnitude square root 3 in the direction of CA. So let's make the circle here. This circle is of radius 6 units. We are given 2 points which are basically the x-intercepts. One of them is A, 6, 0. 6, 0 means this point. Let's say this is A, which is 6, 0. Then we are given B, which is minus 6, 0. That is B. We are given C, which is somewhere here, 5 square root of 11. Point C. Determine a vector of magnitude square root 3 in the direction CA. So in this direction CA, we need to find a vector whose magnitude is square root 3. That is the question. So I hope the question is clear. You can pause the video, answer, and then look into my suggestions. So what is CA? Let's figure this out. So CA, let's say this is O. CA, vector CA will be equal to C2O. You can write this as C2O plus O to A, right? So that is CA, right? So you could write CA as CO plus O to A. So that is CA, correct? So we have C2O is basically 0 minus 5. So we have minus 5 minus square root 11 plus O to A, which is 6, 0. And that gives you minus 5 and 6 gives you 1, and 0, this gives you minus square root 11. Right? You could do like this. You could also do directly. You can do 6 minus 5, which is 1, 0 minus square root 11, that is it, right? So you could do directly also, but that's an alternate way of doing it. Now we need to find a vector which is a magnitude of square root 3 in this direction. So here, first we need to find the unit vector and then multiply by magnitude of 3. Is that clear? So we need to find unit vector now. So to get unit vector in the direction of CA, let's write like this. Unit vector normally with a cap on the top. So will be CA divided by the magnitude of CA, correct? So in this case, our vector is 1 minus square root of 11. We'll divide by the magnitude. That means 1 square plus square root 11 square is 11, right? So that means 1 over square root of 12. So 1 plus 11, which is square root of 12. So that becomes the unit vector times, we can write times like this, right? 1 and minus square root 11. Clear? So that is how we could write this particular vector. Now, square root of 12 is basically 4 times 3, so you can write the 2 square root 3. Right? So either way you could write your vector. So you can write column or row form. So let me write down in the column form once again, 1 minus square root of 11. Correct? So that is unit vector. Now to get a magnitude of square root 3, we are going to multiply this with square root 3, right? So square root 3 times the unit vector CA is our answer, right? So we'll get square root 3 times 1 over 2 square root 3 times this vector 1 minus square root 11. Is that clear to you? So square root 3 will cancel. So you get your answer as half of 1 minus square root 11. Okay? So that becomes your vector. Clear? Or you could also write this as half I minus square root 11 over 2j. Either way. So that is a vector in the direction of CA with the magnitude of square root 3. Is that clear? So that is how you could answer this question. Here are 3 thinking and application questions on introduction of vectors. Question number 9 is, let vector A equals to minus 2, 0, minus 1 and B equals to 2, minus 1, 2. Determine the possible values of x such that A plus xb the magnitude of a plus xb is equal to 5 square root 2. Now let us first find the sum of these two, a plus xb, right? So a plus xb, right? We can say this is equal to vector a, we'll write this as minus 2, 0, minus 1 plus x times we have 2 minus 1, 2. So what you get is minus 2 plus 2x. Here you get minus x, and then we have minus 1 plus 2x. So that is the vector a plus xb. Now when we say magnitude, that means this magnitude 5 square root 2 is equal to square root of sum of the squares of these, right? So minus 2 plus 2x whole square plus minus x whole square plus minus 1 plus 2x whole square root. We can now square both sides. That will give us 25 times 2 equals 2, and we'll expand this. So in the bracket we get 4 minus 2ab, so 8x plus square of 2x, which is 4x square. Here we get x square, and then we have 1 minus 2ab, that is 4x, plus square of 2x, which is 4x square. So we have squared both sides, removing this square root. Now we can simplify. We have 50 equals 2. Adding the x squared terms, let's rewrite. So like common terms, like terms. So 4x square plus x square plus 4x square. Then we have minus 8x minus 4x, and the constants we have 4 and 1. So we have 50 equals to 8 and 1, 9x square, minus 8x and minus 4x is minus 12x, and then we have plus 5. Taking 50 to the left side, we get 9 minus 12x minus 45. Now we are looking for sum and product. We can actually take 3 common here. So taking 3 common, we get 3x square minus 4x, 3 times 1 and 5, 15. So we need 45 as the product, and we are looking for sum of minus 4. So we are looking for a product of two numbers as minus 45 and the sum of P and Q as minus 4. So what could be these two numbers? 9 times 5 can work, so minus 9 and 5. So let's factor. So we get 3 times 3x squared minus 9x plus 5x minus 15. That gives us 3 times. So in this we have a common factor as 3x. So let me write 3x. We have x minus 3. Here we have 5 common, x minus 3. So now we can factor and write this as 3 times x minus 3 is a common factor, 3x plus 5. Right? So that becomes the factored form, and from here we get our solution. Clear? So this will implies that with the value of x, which we can find from here, is x equals to 3 and x equals to minus 5 over 3, right? So since we have this, we have 3 times, let me rewrite, x minus 3 times 3x plus 5 equals to 0. So x minus 3 gives you the value of x as 3, and this factor gives you x as minus 5 over 3. So those are two possible values of x for which we'll get a magnitude of 5 square root 2. Clear? Now let's take question number 10. Question number 10. Given 4 points A 2, 4, 1, B is K 4, 2K, C is K plus 4, 2K plus 4, 2K plus 2, and D is 6, 2K plus 4 and 3. Determine the value of K for which A, B, C, D is a rectangle. Now let's try to understand the question. Let's say we have a rectangle here, and the coordinates A, B, C, D we have to write in a particular order, maybe clockwise or counterclockwise. So rectangle will mean that we have opposite sides as parallel and also these angles at 90 degrees. So that's the meaning. So for 90 degrees, let us find the value of K first, and then we will show that with that value of K, the other sides are all parallel. Okay, so let's work on AB and BC. So let's do what is AB dot BC equals to. For rectangle, AB dot BC should be equal to 0, right? Okay. So AB dot BC, so what is AB? AB, so we are now looking into AB, so which is K minus 2, 4 minus 4, which is 0, 2K minus 1, dot BC. So B to C, let's look into this now. Okay. So K plus 4 minus K will give you 4. 2K plus 4 minus 4 will give you 2K. And 2K plus 2 minus 2K will give you 2. So AB dot BC is equal to 4 times K minus 2, that is 0, right? And this is 2 times 2K minus 1. So that is 8K, sorry, 4K minus 8, and that is plus 4K minus 2. Now, for being perpendicular, that should be equal to 0. So that means 0 equals to all this, right? So now we can simplify this. So we get minus 8 minus, so we get 8K minus 10 equals to 0. And from here, we get 10 equals to 8K, which gives you the value of K as 10 over 8 or 5 over 4. Good. So we get a value of K as 5 over 4. Now, so for 5 over 4, this will be a rectangle. Now what we could do is, we can substitute 5 over 4 and show that they AB and BC, let's find what DC is, and we have to show that AB and DC are parallel. Correct? In that case, that will also be perpendicular to this, correct? So let's find what is DC is, right? So from here we do get AB. AB is basically equal to, we can write from here, K minus 2, 4, 2K minus 1, correct? That is AB. Let's find what is DC. D to C, so we'll take this now. So what we get here is K plus 4 minus 6 will gives us k minus 2. So we are doing DC. So we are doing 2k plus 4 minus 2k will give us 4. And 2k plus 2 minus 3 gives us 2k minus 1. Correct? So that means that AB is actually equal to DC for any value of k. Right? So we know from here that AB and DC are equal. Correct? We have already shown from 1 that for the value of a k, which is 5 over 4, it is perpendicular. Let's calculate what is AD and compare it with BC. So from here, we know BC is basically equal to 4, 2k, 2. Let's find BC. Let's find AD. So AD, so we are now doing AD. So AD means D minus A. So 6 minus 2 is 4. 2k plus 4 minus 4 is 2k. And 3 minus 1 is 2. So we have shown that BC is equal to AD for any value of k. So basically ABCD is a parallelogram with right angles. If k is equal to 5 over 4. Right? So that is the value of k which will satisfy the condition that ABCD is a rectangle. Is that clear? So that means with that we will give a rectangle. So this question is normally asked as in two parts. In part A, we have to show that for any value of k, this is a parallelogram. And part B is to find the value of k for which ABCD is the rectangle, right? So sometimes we add a part here is for any value of k, ABCD is a parallelogram. Is that okay? In short. And part B is determine the value of k for which ABCD is a rectangle. Clear? Now let's take question number 11. ABCD is a quadrilateral where M and N are midpoints of AB and CD respectively. Show that AB plus BC is 2MN. So let's make one so that is a quadrilateral. Any four sides being joined, convex polygon. So let's say this is A, B, C, D. M and N are midpoints of A, B and C, D. So these two sides are equal. Those are the midpoints. Now we need to show that twice MN, that means this, is equal to AB, AD plus BC. Okay, AD plus BC. Okay. So we could write MN from this side. We can say this is equals to MA plus AD plus DN. And MN can also be written as M to B, right? Plus B to C plus C to N. So if we add them, we get twice Mn equals to Ma. So Ma plus Mb. And here we get AD plus BC, and we have DN plus Cn. Now as you can see, MA plus MB, because AM is equal to MB, right? AM is MB. So we can write MB as minus MA also. So minus MA is equal to MB. Correct? So from here it is clear that MA plus MB is equal to 0. So this part is 0, right? So we have 2Mn equals to 0 plus AD plus BC, right? Now as far as DN and Cn is concerned, they are also add to 0, right? So that is also 0. So we have shown that 2Mn is equals to AD plus BC. Clear? So that is how we are going to prove it. Now let's take the last example. Number 12 here is, given coordinates of points A 2, minus 1, 2 and B 2, minus 2, 5, find position vector of the point P which divides the segment AB in the ratio of 1:2. You can always pause the video, answer the question, and then look into my suggestions. Now let's try to understand the situation, right? So this is just an illustration to help us answer the question. Let's say the point A and B are given here on the segment, and we have a point P which divides AB in the ratio of 1:2, right? So that is the situation given to us. We need to find the position vector of this point P. So that really means that on a coordinate plane, it looks something like this. We want what is OP. This is what we are interested in finding. Clear? So OP can be written as a combination of O to A plus A to P. Right? So that is how we could find it. So we can say that OP is basically equal to OA plus AP. Now, AP is 1/3 of AB, right? So total is 3. So A to B, if we have this as 3 units, right? Then 1:2. So we can say that AP is basically 1/3 of A to B. So it is 1/3 of A to B. A to B, these are the coordinates. So 2 minus 2. Minus 2 minus 1. 5 minus 2. So that gives you, sorry, 1/3. So 1/3 of 2 minus 2 is 0. That is minus 1. And this is 3. So this is basically, you could write in this form also. So AP is, okay, let's keep it like this. That's what it is. Or you can say 0 minus 1/3 and 1. Clear? Okay. So now we have AP. We can now find what OP is. So OP will be OA. OA is given to us as 2 minus 1, 2 plus AP, which is this, 0 minus 1/3 and 1. So that gives you the value as 2 minus, so that gives us minus 3 minus 1 as minus 4/3 and 2 plus 1 as 3, right? So we get OP. So OP is basically, you can write this also as 2i minus 4/3j plus 3k. Right. So these are unit vectors, I, j, k. So that is method 1. Let me call this as method 1. Okay. Here is an alternate method. Which we work on line segment. So we have examples on division of line segment. So where we use section formula. So I'm not getting into details of this. There are some references which you can check. I'll provide you with the link. Okay. So from there we can directly get the value OP. So OP directly will be equal to 2 times OA plus 1 time OB over 2 plus 1. So that helps you to get direct result. 2 plus 1 is 3. 2 times OA is, let's do this, 2 times OA is 2 minus 1, 2 plus OB, which is 2 minus 2, 5. Right? This is a shortcut. Okay. So when you do this, you get what? 1/3 of 4 plus 2, 6 minus 2 minus 2 minus 2 is minus 4. And 2 times 2, 4. 4 plus 5 is 9, right? You get the same result, which is 6 divided by 3 is 2, minus 4 over 3, and 9 divided by 3 is 3. Do you see that? So you get the same result, which we got earlier, correct? So that is how you could do it. So I hope the steps are absolutely clear. So follow the method which you like. So this is from basics, you understand how to do it. Here, we have not derived the formula, right? So basically the formula is that it is, if the division is m is to n, in that case n times OA plus m times OB over n plus m. Is that okay? So that is the formula which we have used here. So anyway, I hope you understand all these steps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.